Okay, section 9.3, rotations. Rotations are a little more complex than translations or reflections, but hang in there, it'll be all right. We will get through it. So here is what you're doing. When you're rotating around a center of rotation. That point can be outside of the figure, inside of the figure, or even on the figure. And so when you're doing a rotation, that means you're twisting it around. You're always going to be rotating it in a counterclockwise manner because think of the unit circle, like this is 0 degrees and then 90 degrees and then 180 degrees and then 270 and then 360. So you're always going in this counterclockwise motion. So here are the steps. The first thing you do is draw. I've already drawn it here, but I want to show you how I got it. You draw a segment from the point of rotation to one of the vertices. And so we'll just do it like to O, okay? So the reason that you're drawing this first little guideline here is because that's actually going to be your 0 degrees on your protractor. Why? Because it hasn't rotated at all. It hasn't moved. So if you'll notice, you'll line up your protractor, and again, you have to know how to use a protractor. So a protractor, you're always going to put the center in this little hole, and these lines right here are going to, well, the one on the right is going to line up with your first guideline. This is 0 degrees. You'll use the bottom scale because the bottom starts with 0, then 10, then 20, and so forth degrees. And so you're going to want to use the bottom scale every time. If you try to use this top scale, look, you're not going in counterclockwise motion. You're going clockwise. So you always need to use the bottom scale. Okay, so you'll have to move your paper around so that you can see this 0 degrees. And you'll line up this guideline that you just drew very lightly with 0 degrees. And it says in the example that we want to rotate everything 110 degrees. So you're going to look at the bottom scale, and this is where 110 degrees is. So you'll put like a little light dot. Now this dot right here is really huge, so try to measure everything from the very center. All right, so you'll do it really lightly. So this is where 0 was, and this is 110 degrees in a rotation around this dot. And you'll notice the new O, not 0, the new O is here, and so I labeled it O prime. Now, how did I know how far to go? Well, you use your index card or some form of measure, and in this case, this was how far the O vertex was from the center of rotation. So then you'll use the same measure to say this is how far the new O is from the center of rotation. So then I just marked it. Now notice that there's no guidelines here, and that's because after each time I did that, I erased these guidelines so that we don't have a million little lines here to kind of complicate the situation. So we did that with every single one. We drew a line from P to L. That was our 0, measured 110 degrees, and found the new L prime. Drew a line from P to M, measure 110 degrees counterclockwise, and that's where M is. And then when we were done, we connected the vertices together. So let's do one together. All right, so the first thing we need to do is draw a line segment from K to any vertex. I'm just going to start with R. It doesn't really matter which one. And that's now our 0 degrees. Our 0 degrees. And we want to, this one asks us to rotate everything 75 degrees. So 75 is right here. So my new R is going to be on this new line because we just went 75 degrees in a counterclockwise way. Now we need to have it the right distance. So we'll do this. Oh, looks like it's right here, this longer. And then we'll measure it along this one because we want the R to be the same distance away from the center of rotation. Now that I'm done with these guidelines, I don't need them anymore. I made sure that I made my point kind of dark so I could get a hold of it, and I labeled it. Now let's do S. Again, it doesn't really matter what order you do it as long as you keep track of what you're doing. Okay, this is now going to be my 0. The first line you draw is always your 0 degrees. So I'm going to line up my S. I want to go 75 degrees. Here's 75. I don't need to draw this long of a line because I know that S is not that far away. I can just draw it a certain distance, enough. And then the S is going to be about this far away. And so that means that my new S is also going to be about that far away. And I make my point kind of dark so that when I erase my guidelines, my point isn't gone, it's still there. Okay, let's do T. I'm drawing a line from the center of rotation to T. That's my 0. Now I'm going to have to turn my paper all the way upside down because 0 is on the right side. 0 means it hasn't been rotated at all. And I'm going to go 75 degrees. And then I'm going to draw a guideline here. I need to measure the distance to T. The distance to T is here. And so the distance to the new T will be the same distance away. When I rotate it around, I don't change how far away it is. I just change what angle it's at. Erase these guidelines because they get kind of in the way. Go ahead and label T prime so I don't forget. And then the last one is Q. So the first line is always from the center of rotation to the vertex, and that gives you your 0. And again, your 0 needs to be on the right side of your protractor. 75 degrees. Okay, it's kind of far away, so I'm going to measure that to go to Q. Was about to here, Q, and then the new Q, kind of dark. Now, it doesn't really matter if you leave those guidelines, but I like to kind of clean them all up just to make the thing look a little bit nicer, easier to read. So then I take a colored pencil of my choice and connect the 4 new vertices. And these 4 vertices make my rotated image. Remember, we rotated the image around this center of rotation, which was inside of the figure. So it's going to be like that. Outside the figure, it's going to still be outside the figure. 135 degrees is pretty far. It's all the way around like this. So it's going to go pretty far around. Okay, so let's do our steps again. Going to draw a line to one vertex, and that is our 0. So we'll have to move our paper all the way around so that it's in that first quadrant. And we want to go 135 degrees, which is here. So this is a 135 degree angle. So B is now going to be on this new section. So let's find out how far B is. Here and here, and I'll make it kind of dark but not too huge. You don't, the bigger you make your dots, the more inaccurate your measurements and your drawings are. Go ahead and label it before you forget what you've already done, because once they start moving around, things can get kind of complicated. All right, so A. And this is our 0 degrees because it hasn't moved, so I'm going to have to turn my paper all the way upside down. And A is going to move 135 degrees. Okay. And A is here. A is, the new A is here. Kind of make it dark. Label it so you don't forget what you're doing. A prime. All right. And then D. This is my 0. So I spin this around because we have to go counterclockwise. 135 degrees is here. All right, and D is going to be this distance. Okay, and then go all the way the same distance over here. Wow, on the same. So this is D prime. And Erase. And C is the last one. So draw a line from K to C. This is our 0. And then we want to go 135, rotate 135 degrees. I didn't draw that line perfectly, so I'm going to adjust. The line's a little bit below the vertex. I'm going to adjust it. This is 135, so C is now going to be on this segment. And we need to see how far away it was. C is here, and the new C is here. Trace your guidelines. All right, so B prime, C prime, and then this is why those dots have to be kind of small, because if they're really huge, then your figure can be distorted when you go to draw it. Okay, so this figure has been rotated 135 degrees around that center of origin. We're going to pick up on how to rotate on the coordinate plane in the next video.